Okay, this is lesson 5. In the previous lesson, we learned how to divide using long division. In this lesson, we're going to learn how to use a quick little method for dividing that you can use only in special cases, okay? So f of x divided by d of x, and d of x is the form x plus a number. That's what I mean by x plus a, or x minus a number, like x minus a. Then you can use the process called synthetic division. So synthetic division is a neat little trick that we can use to divide, but it only ever works when you have something like this, x minus 3. So if we go back, to the previous problems, we could have used it on x minus 1, x plus 1. Could have used it here. Not here, right? Not there. Not on this 3x minus 1 either. So it has to be just an x plus or minus a number. So it can be helpful, but you can't use it all the time. But we will be able to use it a lot in our coming up lessons. So we're going to use synthetic division to divide. So here we go. Instead of drawing a house, we draw a basement. Take the coefficients of the polynomial. So we have 1x to the fourth, negative 3x cubed, negative 1x squared, positive 5x, and positive 2. Now, if there's a missing degree, you have to use 0 for the missing term here. There's no option. You'll just get it wrong. Then what you put here is the opposite of that number, 3, for reasons that you'll figure out as we go along. Okay, first step in synthetic division is to take this number and bring it straight down. Then multiply 3 times 1 and you get 3. 3 times 1 is 3 and you put it there. Then you add. Negative 3 plus 3 is 0. Then you multiply 3 times 0 and get 0. And then you add and you get negative 1. 3 times negative 1 is negative 3. Then you add and you get 2. 3 times 2 is 6. Then you add and you get 8. All right, now this is the remainder. And this is the quotient. And since we're dividing by a linear term, this will always start 1 degree less than that. You could also think of it as the remainder, the constant, x to the first, x to the second, x to the third. But most people just think, okay, x to the fourth, so now this is x to the third. So my quotient is 1x cubed plus 0x squared minus x plus 2 plus my remainder over my divisor, which was x minus 3. So hopefully you see that as less work, but it is kind of a strange process. This is called synthetic division. All right, let's try the next one. 1, 0 for the x cubed, negative 3, 2, and negative 1. And you just got to be really careful. If you forget the 0, you're just going to get it wrong. With the long division, if you don't put the zeros, you'll see that it doesn't line up right. But with this, you'll think you're doing it right, and you're not. So just be real careful. All right, we want to take the opposite of that number, so it's a negative 3. Bring this number straight down. That's the first step. Bring it straight down. Then you multiply, and you get negative 3 times 1 is negative 3. Then you add. Then you multiply. And then you add. Multiply. Add. Multiply. Add. The result always goes down a degree. It was x to the fourth, so it's now 1x cubed minus 3x squared plus 6x minus 16 plus a remainder of 47 over the divisor x plus 3. So go ahead and practice those two. Okay, so what you should do is write down the coefficients. There's no gaps, I don't think. So then you just take the opposite of that number and put it there. Bring this number straight down, and then multiply, multiply, multiply. And so our answer is x squared minus x plus negative 5 over x minus 1. All right, on the next one, I've got 1x to the fourth, 1x to the third, negative x squared, a single x, and then a minus 2. And we're going to put a negative 2. So I bring down the 1. Negative 2 times 1 is negative 2. That's a negative 1. 2. It's a positive 1. Negative 2. That makes that a negative 1. A positive 2, and that's 0. So this is simply x to the third minus x squared plus x minus 1. So apparently this was a factor because it had a remainder of 0. All right, let's try synthetic division, this time stating our result in quotient and remainder form. So it's not going to be that we're saying this is equal to quotient and remainder. We're just going to be expressing the same information in a different way. So I have 1x to the fourth, negative 2x cubed, 0x squared, negative 22x, and then a negative 1. Put a 4 there, bring down the 1. So 4, 2, 8, 32, 10, 40, and 39. So our quotient and remainder form would be x cubed plus 2x squared plus 8x plus 10 times x minus 4 plus 39. That is what is equal to x to the fourth minus 2x cubed minus 22x minus 1. So that's an unusual way to say the answer to a division problem. Usually you would just say the quotient plus the remainder of the divisor, but I just want you to see that. So you have a practice problem here to do like that. I'm going to ask that you do that on your own, and we're going to move on to a different example. All right, so this is where I wanted to get to so you can see why we're doing this. Given this function, f of x equals x cubed minus 5x squared plus 3x plus 2, I want you to use synthetic division to divide f of x by x minus 3, and we'll state our result in quotient and remainder. So synthetic division, I need the coefficients, and we put the opposite of that x minus a. Put the 3 instead of the minus 3. All right, bring this straight down as a 1. 3 times 1 is 3, and that's a negative 2. Negative 6, that makes that a negative 3, and then that's a negative 9, so it's a negative 7. You know, in standard form of describing the answer, we would say this is x squared minus 2x minus 3 plus the remainder over the divisor. But I can also say that since we divided f of x by x minus 3, this must equal the quotient, x squared minus 2x minus 3, times the divisor plus the remainder. So that's another way for me to describe f of x. that f of x can be written out like this. Let's use our result from part A to evaluate f of 3. So I need to evaluate f of 3, and I have two choices how I can do this. Well, it said use your result, but if it didn't, let's talk about my options. I could plug 3 in here and do 3 cubed minus 5 times 3 squared plus 3 times 3 plus 2. Yuck, right? Instead, let's use this. 3 squared minus 2 times 3 minus 3 times 3 minus 3 minus 7. Now, I'm going to say I don't actually care what this is. Because what's 3 minus 3? 0. 0 times 0 is 0. So it's actually just negative 7. So when I evaluated this here, at that value that's the opposite of that minus 3, it turns out to just be that. That's an important concept. I want you to practice that one. Okay, so on this one here, we should use 1, negative 2, negative 3, negative 5, 8. And we're going to be dividing by x plus 2, so we put a negative 2 there. Bring the 1 straight down. Whatever this number is, comes straight down. Negative 2, and then that's a negative 4. 8, and then that's a 5. Negative 10, making that a negative 15, and then making this a 30, and then making that a 38. Did I do my math right? Yes. So f of x then is x plus 2 times x, it used to be x to the fourth, now it's x cubed, minus 4x squared, plus 5x minus 15, but we had that extra remainder. But this makes evaluating at f equals negative 2 super easy, because that makes this negative 2 plus 2 is 0, and I don't care what this is. So the answer is just 38. So how can we summarize that? We can summarize this with a theorem.
I love theorem.
Well, I'm glad that we have such a positive reaction to theorems. The remainder theorem states that if a polynomial f of x is divided by x minus a, then the remainder is equal to f of a. So that's a pretty cool theorem. It's saying, hey, you learned how to do synthetic division. You learned how to do long division. Fantastic. You didn't know it, but every time you got the remainder, you were actually also evaluating the polynomial. And quite often, synthetic division is easier than actually using direct substitution of the number. All right, so here we go. We got this polynomial. Let's use it. Let's use the remainder theorem to evaluate f of 2. So I will simply do synthetic division. 2x cubed, negative 3x squared. Got to have the 0, though, for the x, and then the 1. So I'm going to plug in what would go here? Well, let's remember. F of 2 means I'm dividing by x minus 2, right? But that means that I put a positive 2 here, which is why some mathematicians will claim that they'll call this synthetic division, they'll call it synthetic substitution, because it begins to look a lot more reasonable why this number is the opposite of that number, because you're simply evaluating at it. All right, first step is to bring down the first coefficient. That 2 comes straight down. Then we multiply, we get 4. So add and you get 1. Multiply, you get 2. 4, and then 5. So the answer must be 5. And we could, this one's not too bad to plug in. 8, 16. 16 minus 12 is 4, plus 1 is 5. So it works. But, this was easy. Let's do negative 1/2. I don't know about you. I don't want to put negative 1/2 in there, do you? No. So we're actually dividing by x plus a half. which means we put negative a half there. So it ends up being exactly the number we're evaluating it. Bring down the 2 and multiply. You get a negative 1. Remember to, when you multiply a whole number times a fraction, divide by the denominator first. 2 divided by 2 is 1. 1 times 1 is negative 1. That's a negative 4. Okay. Negative times a negative is a positive. 4 divided by 2 is 2. All right, and then that gives me, what was that, negative 1? Oh, got a 0. So that must be a 0 of the polynomial. All right, let's try x equals 1. Bring down the 2. Negative 1. That's a negative 1. And that's also a 0, isn't it? So we actually found a couple of zeros because they had 0 for a remainder. All right, so go ahead and practice. Go ahead and go through them. All right, so let's see how we did. First, write down the coefficients. Make sure that there's no skipped terms. I don't think there are in this one, though. And we'll put a 2 there. And bring this down. Negative, what is that? Negative 46. So negative 36 is the remainder. So that must be what you get. Let's try the next one. So you can't use you have to use long division when you divide by something like x squared plus 4 or 3x minus 5. You can only use synthetic division when it's x minus 6, x plus 2. It has to be x and then plus or minus. But if there's a squared, you can't do it. You can always use long division, though. And the remainder theorem would still hold. Two, 10, negative 1. So that must be a 0. We found a 0. Let's try negative 3. And negative 6, and then 18. Was that 7? Negative 21. Negative 18, I think, and then 54, yeah. So 64. Okay, so here's an important theorem that I think we discussed before, the zero factor theorem. States that if you have a 0, like if x equals a is a 0, then x minus a is a factor. We've talked about that before. We see it now coming up again. We've got a remainder of 0 here when we divided by x minus 5. We divided by x minus 5. We got a remainder of 0. We know from our definition that means x minus 5 is a factor. And we also know that y of 5 then equals 0. So we know 5 is a 0 and x minus 5 is a factor. We find that out at the same time because the zero factor theorem says that's basically saying the same thing. If I say 5 is a 0, you could hear that as x minus 5 is a factor. All right, so let's take a look at how we can apply that knowledge. Given that x equals 3 is a 0 of this polynomial, can we fully factor it and find the other real zeros? I want to point out that this is definitely not groupable. The ratio from this term to this term is not the same as that term to that term. If you recall from back in the previous lesson 2, we talked a little bit, 2 or 3. I think it's 3. We talked about when things were groupable. Well, we couldn't use grouping here. We'd have to use some sort of division. So let's use the fact that x equals 3 as a 0. So I can use long division or synthetic. Okay, we'll do synthetic since that's what we've been studying. But it wouldn't be too much more difficult to use long division. and I'll put a 3 right here. I'm dividing by x minus 3, but I put the x value. Bring the 2 straight down and multiply. Okay, that becomes a negative 9. That becomes a negative 5, and that becomes a negative 15, which is 0. And that's good because they told me it was 0. I'm glad that I got it right. or they weren't lying to me, right? Well, what that means from the kind of the quotient remainder form is that we can describe f of x, which was originally this. We can describe it now as x minus 3, that's the divisor, times the quotient, 2x squared, it was x cubed, now it's 2x squared, minus 9x minus 5, plus the remainder of 0. We just factored f of x. Now that I have it down to a quadratic, I can try factoring that as well. Let's set it equal to 0 and do that. I'll make that a negative 5 and a plus 1. Now, if I hadn't been able to factor that, I could still find zeros by using the quadratic formula. Now I'll set each factor equal to 0. This one I already know, because they told me it was x equals 3. That'll be a negative 1/2 and 5. So the real zeros are 3, negative 1/2, and 5. And that, that might seem like kind of a silly problem. Like, well, they gave me part of the answer. But it turns out that in lots of situations, you'll know one of the zeros just by the very nature of the problem you're trying to solve. All right, so let's finish up by doing this one together. Given that x plus 6 is a factor, we can divide by it, and we put a negative 6 there. Bring down this 1. Multiply, and you get 30. And so we can see that we could factor f of x as x plus 6 times x squared minus 5x plus 4, which can be factored further as x minus 4, x minus 1. So our zeros are negative 6, positive 4, and positive 1. So what does this all mean? What's the big picture here? It's telling me if you have a function f, all of these statements are equivalent. This is absolutely essential. A is a 0 as f. What does that mean? F of a equals 0. X minus a is a factor. And the remainder when you divide by x minus a is 0. All of those statements are equivalent. Given any one of them, you can conclude all of them. So we can play a little fill in the blanks here. If x equals 3 is a 0 of f, then f of 3 equals 0. The remainder when dividing by x minus 3 is 0. And x minus 3 is a factor. All right.